Good morning, or afternoon, or evening. I don't know when you're watching this, but welcome to the Number Sense video workshop. So, for those at home, make sure to at least remember a couple of the names because they might be asked at the end of the video or a questionnaire, probably. I don't know. But so we'll get right to it. So starting the workshop. We're going to have the double and half trick. So what it is basically if you have two numbers that are multiplied, let's call them A and B, then the idea is if you multiply by 2 over 2, it's the same thing as multiplying by 1. So you could rewrite this as twice A times half of B, or the same thing as 1/2 of A times twice of B. So the trick can be helpful in some cases, but it's just it could be kind of common sense. So for instance, if you were dealing with numbers 12 times 4, for instance, you could rewrite this as 24 times 2 by multiplying this by 2 and dividing this by 2. Or, I mean, you could rewrite it as this divided by 2 and multiply this by 2. 6 times 8. Whatever is easier for you to solve. I mean, a lot of cases probably you would just want to condense the 2 digits to 1 digit. So it's probably easier to solve. I think most people have 6 times 8 memorized, but not 12 times 4 memorized. So 6 times 8 would be 48. And that's the same thing as 24 times 2. So that should be correct. Oh, sorry, this is a 4, by the way, not a 9. But yeah, so the trick's pretty self-explanatory, but it's not just for double and half, so it's kind of deceiving. It's more like this. So it would be more like a constant divided by a constant. So it would be k divided by k. K times A times 1 over K times B, or 1 over K times A times K times B, because K divided by K is 1 for all cases except for K cannot be 0. So if K was 0, well, you can't divide by 0, so it wouldn't work out. But so it could be the third and triple trick. I don't know. If you want it to be, it could be the quarter and quadruple trick. Up to you. But yeah, so it can be handy. I mean, especially if you want to deal with things like decimals, maybe. So if you're dealing with the case where you're dealing with let's say 2.5 times 8. If you want to get rid of a decimal, well, you can multiply this by 2 and divide this by 2. So 2.5 times 2 is 5 times 4, which is 20. And just to be sure, I'm just going to have a calculator out to double check my work. And that's correct. So yeah, that's about it for the first trick. It's pretty self-explanatory because essentially you're just multiplying by 1. So you're not changing anything as far as the multiplication goes. It's just rewriting it for your own preferences. So that's the first trick. Double and half. For the second trick, we're going to have, I couldn't think of a name for it, but I'm going to call it the popular fractions to decimals trick. So essentially, this trick is really helpful if you know common fractions or decimals. Like 1/2 is 0.5, 1/4 is 0.25, or I mean 1/3 is probably not going to be helpful in this case because you're going to be dealing with 0.3333 to infinity, so that won't work. But 1/8 is 0.125, etc. So what this trick is if you memorize these, you can make correlations between other numbers whenever you multiply. For instance, if you're going to multiply by 5, so if you're multiplying a number times 5, well, 5 is the same thing as a times 1/2 times 10. Because we know 1/2 is 0.5. If we multiply that by 10, we move the decimal place 1 to the right. So essentially what this is, I'm saying that word too much, but if we divide a by 2 and add a 0, we can multiply by 5. So if you probably do this by accident, but 8 divided by 2 is 4 times 10, which you're doing the double and half trick accidentally, but so you're dividing by 2 and then adding a 0. So 4, add a 0. That's how you solve for multiplying by 5. So 16 times 5 is 16 divided by 2. 8, add a 0. 12 times 5. I mean, it works better whenever you have even numbers in this case. So 6, add a 0. But if it was odd, it's still simple, I think. 7 divided by 2 is 3.5, add a 0, or move the decimal place once, you're going to have 35. So that's by 5. If you're doing it with 25, you could have, for instance, 8 times 25. Well, a times 25 is the same thing as a times 1/4 times 100, because 100 divided by 4 is 25. Or, yeah, 100 divided by 4 is 25, or 0.25 add 2 zeros is the same thing as multiplying by 100. So 8 times 25, I mean, that one you could probably already see it because there's 4 25s in 100, so multiply this by 4, multiply this by 2. If you wanted to rewrite that as 2 times 4 times 25. But the idea is you could just divide 8 by 4, so you get 2, and then add 2 zeros. I'll do one more example. 16 times 16 divided by 4 is 4. Add 2 zeros. In that case, let's just double this, which makes sense because if I add a 2 here, we're multiplying by 2 here to get this. And then same thing with 125. In that case, you're just going to divide by 8 and then add 1 more 0. So because 125 is the same thing as a times 1/8 times 1000, because 1000 divided by 8 is 125. So yeah. So that's the popular fractions to decimals trick by my own naming convention. Third trick I'll show is, I'll call it just the phrase it is. We say percentages are reversible. So in other words, A% of B is the same thing as B% of A. And at first, so that might be weird to look at. I mean, but I'll explain why that is in a sec. But if you're looking at, for instance, 4%, oh, that's 4 times. Anyways, 4% of, let's say, 25. Well, 25% of 4 is the same thing. So if you know 25% is the same thing as 1/4, so 1/4 times 4 is 1. So a quarter of 4 is 1, makes sense. So 4% of 25 is also 1. So reasoning for this is, well, A%, if we go by the definition of percent, that's the same thing as A divided by 100 times B. And then we see that B% of A is the same thing as B divided by 100 times A. Since we're dealing with a product of numbers, it doesn't matter which order we multiply in. In fact, we could expand this and say that A times B divided by 100 is also correct. So depending on what problem you're given, sometimes it's easier to just rewrite it if it's not easy to see initially. So if you're looking at 3% of 4, for instance, then it might not be that helpful to use these two methods, and it might actually be best to view it like this. So in this case, 3 times 4 is 12, so 12 divided by 100 is 0.12, so your answer would be 0.12 or 12%. Yeah, 0.12 is probably is the same thing as 3% of 4. And it makes sense because it's a really small number. But if you were, yeah. So the idea is if you flip the which one is the percentage of the other one, then it's also a true statement. Yeah. So those are the first 3 tricks. I'll go on to the 11th trick. It's pretty neat. Although it doesn't just apply to 11s, it applies to any combination of 1s or 0s for whatever you're multiplying by. So this one's cool. So if we multiply by 11, it's the same thing as writing the first digit down that you're multiplying by and then adding 2 digits until you get to the last digit and just write it down. Which sounds weird at first, but I'll just write an example. So 123. What we do is we take the 1's digit and write it. We add 2 digits, so the 10's digit and the 1's digit, since 2 plus 3 is 5. Then we go on to the next 2, so 1 plus 2 is 3. And then we write down the final digit, which is just 1. So 11 times 123 should be 1,353, and that's correct. If we're dealing with, yeah, so I'll do one more example. In fact, I'll just have 11 times this. So 11 times 1,353, write the 1's digit, add digits, so 5 plus 3 is 8. 3 plus 5 is also 8. 1 plus 3 is 4. And then we write down the final digit, which is 1. And that's how you multiply by 11. Yep. So, let's kind of do this for any combination of 1's and 0's. So what I like to do is just use my fingers for multiplying by a combination of 1 or 0. So essentially your hand is going to have fingers up for whenever you're multiplying. So in this case, I like to put up 2 fingers for the 11. And what I do is I move 2 fingers starting with the index finger, and then I just add whatever is up on my fingers. So here, the 3 is at my index, and then there's nothing here. So 3 plus 0 is 3. I write it. 2 plus 3 is 5. 1 plus 2 is 3, and then 1, so that's what we already solved. But if we're doing with another combination of 1s and 0s, as in 11, 101, 110, etc., what it is actually the reflection of your fingers here. I'm gonna actually add one more digit to show this. So if we have 1101, it's actually going to be the reflection for your fingers. So in this case, it's whatever is here, and then you flip it. So now you're going to have 1, so you write down a 1. Then you shift it in one place, so now you're still just having one number that's added, so it's 2. At my pointer finger, here we have my pointer and my ring finger on a number, so it's 3 plus 1, which is 4. It's hard writing with my left hand. Here is 2 plus 2 plus 1, which is 4 plus 1, which is 5. And then I shift it one place. 1 plus 3 plus 2, which is 4 plus 2, which is 6. And here, if I shift it again, we get 2 plus 3, which is 5. If I shift, we get 2 plus 1, which is 3. And then we write down the 1. So that's how you multiply by combinations of 1s and 0s. Is what you do is you could put your fingers up for whatever the numbers are, and then you reflect it, and then you move it like move it one digit each time and see which numbers are correlating with your fingers, and then you just add it. So let me double check that one so I know I'm not lying to you. So 1,101 times 12,321 is indeed 13,565,421. I mean, okay, so just on a side note, don't multiply by 10 with this trick, because if you do it, you're going to get you're essentially going to flip people off, which is no bueno. So I'm not going to do that. In fact, it's much easier to just add a 0. But if I were to do the same process, I'm going to use my ring finger and pretend that's the scale. So if we have the pinky at the 0, then here we add 3. No, we add 0. So what I did was just put it right down as 0. Then we just get 3, 2, 1. So it still works with that. It's just much easier to just put a 0 at the end, which you've probably already been taught. But yeah, that's the 11's trick, or multiplying by any combination of 1s of 0s, or just 11. If 11 is all you remember, then that's cool. But yeah. We're 4 tricks in, so we're going to give away today's secret word, which is factor. F-A-C-T-O-R. If you are watching this video, then this word is what you're going to need for one of your questions. And I think the word goes hand in hand with the tricks that are shown today, because we're dealing with multiplication, and factors are used to multiply to get a product. So I'm going to keep that up there for a bit. I don't know. Maybe decorate. Secret word? I don't know. But yeah, okay. So now we're going into the tens trick. So for this one, I'm going to write down how it's created, and then I'll explain it. So I'm going to have 2-digit numbers that are multiplied. So 10A plus B times another 2-digit number, which is 10A plus C, where the tens digits are the same and the units, one's digit, add up to 10. So b plus c equals 10. So I'm gonna go ahead and solve this, which would be 100 a squared plus, that would be 10 ab plus 10 ac plus bc. So if I were to write this, we get 100 a squared plus 10 a times b plus c plus bc. But b plus c equals 10, so I could put the 10 inside of here to get 100 a squared plus 100 a plus bc. And then finally the last step would be to factor out the 100 a's. So we get 100 a times a plus 1 plus bc. And right now that looks like nothing and has no purpose to us until we actually have a problem that follows these conditions. So I'm going to erase the secret word. The secret word is factor. So, yep. And I'll erase my work up to this thing at the bottom. So, yeah, that's how it's made real quick. In this case, yeah, I'm gonna rewrite this down here. So 10a plus b times 10a plus c. I don't know if the camera can get that, but cool. So essentially, the tens trick is this, and I'll put an example. So if I have 67 times 63, where in this case the tens digit is the same, so it's 6, and then the units add up to 10, so 7 plus 3 is 10, then we could do this trick. So in this case, if we were going by the formula directly, a equals to 6, b equals to 7, because so it's 60 plus 7 is 67 times 6 times 10, which is 60, plus 3, so c equals 3. If we were using the formula directly, we'd get 100 times 6 plus 1, which is 7, plus b times c, which is 7, times 3. If we were going directly by the formula, we get 4,200 plus 21, and then all we get is 4221. But what if we have the formula memorized, then all we need to do is remember the process. So in this case, all we do is multiply the ones digits, so 7, 14, 21, write it, and then 6 times the number after 6, which is 6 times 7, which is 42. If we remember the process, then the steps are much easier, and we don't need to actually look at the formula for it. So if we write down another example, we'd have, yeah, I'll note it afterwards. But here we have 36 times 34. This still applies to our rule because the tens digit's the same and the ones digits add up to 10. So 3 and then 6 plus 4 is 10. We'd get 6 times 4, which is 24. 3 times the number after 3, so 3 times 4 is 12. So 36 times 34 is 1,224. Correct? So yeah, one thing to note is the one case where this is going to be a little weird is if you have like 29 times 21. All we'd have to do is make sure that we leave space between this and this. So 9 times 1 is 9, but we need to add a 0. That's the one thing. because here we have 100 times 8 plus 1, so in other words it's shifted 2 placements before you actually do the product of 2 and the number after 2. So whatever b times c is has to be within 2 digits for this to work. So 1 times 9 is 0, 9, and then 2 times the number after 2, which is 2 times 3, is 6. So anytime you have 9 and 1 for the one's digits adding up to, you have to leave a 0 between it, otherwise you're going to get 69, which is not correct from 29 times 21. But yeah. So that's the tens trick. If you have any questions, stop by the office. Next trick I think we're going to cover is call it the equidistance. I don't know, is it equal distance? I'll just say equal distance trick. So what it is if you have numbers that are multiplied that are within the same distance of a number, you can use this trick. So if we have 10a, no, actually let's just put a. So if we have a plus b and multiply by a minus b, or b is the distance from a certain number and a is that number, then you could rewrite this as a squared minus b squared. And that's after, if I wanted to write it out the long way, we get a squared plus ab minus ab minus b squared. So the a times b would cancel out because you're adding and subtracting by itself. Well, you're subtracting by itself. So what this trick is used for is if you have a certain distance from a number, it's easier if the number is a multiple 10. So if we have 22 times 18, they're both 2 units from the number 20. So here we have 20 plus 2 times 20 minus 2. So essentially 20 squared, which is 400, minus 2 squared, which is 4. 400 minus 4 is 396. So 22 times 18 is 396. And that's correct. If we have another example, we can do 33 times 17. So that is, oh wait, no, 27. That'd probably be easier. 33 times 27, so they're 3 units from 30. So this one's 3 more, this one's 3 less. So what we do is we take 30 and square it. So 30 times 30 is 900. 900 minus 3 squared. So 900 minus 3 squared, 3 squared is 9. 900 minus 9 is 891. So 33 times 27 is 891. So yeah, the numbers don't have to be equal in distance from a tens number, but it's much easier if it is. If, for instance, you memorize your squares, this will come in handy. So if you know, well, let's do 13 times 11. So for this trick, for this one, you could use the 11s trick, which we've been shown, which is you write down the number and then add the 2 digits, so we get 4 and then 1. But if you're using this trick, you'd get, since they're both equal in distance from the number 12, so in other words, the midway point is 12 from 13 and 11, and they're one unit away from 12, then we get 12 squared, which is 144, minus 1 squared, which is 1. So that'd give you 143. So in other words, we got the same thing twice using either the 11's trick or the equal distance trick. And yeah, you could use it for anything. It doesn't have to be 2 digits. It could be 1 digit. For instance, you could have something like 7 times 5, which we already know is 35 by either doing it, either memorizing your multiplication tables or by using the double and half trick like we've seen, where we get this divided by 2, move the decimal once we get 35. But if we were to use this trick in particular, the midway point is 6, so 6 squared is 36 minus the distance of 1 between them, between 6 and 1 squared. So 6 squared is 36 minus 1 squared, which is 35. So depending on, if you know a few tricks, you could decide on how you want to approach the problem. It's all based off of what is easier for you. So yeah, this is equal distance trick. Next one I have is the 2-digit square trick. So if we have 10 times a plus b and we square it, if we write it all out, we get 100 a squared plus 10 times 2ab plus 10, plus b squared, because this is the same thing as 10 times a plus b times 10 times a plus b. And if you were to write everything out, you get 100 a squared plus 2 times 10ab plus b squared. But this is essentially all you need for this trick. So if you have a square, a 2-digit square, you could have, let's say, 32 squared. If you don't have that memorized, well, you could just use the trick. So b is 2, so 2 squared is 4. Then you take these 2 digits and you multiply them by each other and then double it. So 3 times 2 is 6, double it, you get 12. So you carry a 1. And then 3 squared is 9, add the 1, you get 10. So 32 squared is 1024. I'll do this one a few times because it's kind of weird doing the process. So 46 squared is 6 squared, which is 36, carry the 3. So now we have a 3 carried. 6 times 4, which is 24, double it, you get 48, plus the 3, you get 51. Carry the 5 now. 4 squared is 16, add 5, you get 21. So 46 squared is 2,116. So that one might be tricky to memorize, but if you do, 2-digit squares will come in handy. So essentially, the 1's digit is being squared, then you multiply the 2 digits and double it, and then you take the last one and then square it. So you square, and then in the middle you multiply and double it. So that's kind of how I memorize it. So we could do one more, well no, 2 more, probably. I'll rush through this next one, maybe, because it's pretty complicated, but I'm gonna do 3-digit squares, and that one's gonna use a longer formula. So I'll go ahead and get to it. So 3-digit squares, that is 100 times a plus 10 times b plus c squared is equal to 1, that's 10,000 a squared plus 1000 AB plus 100 AC plus 1000 AB plus 100 B squared plus 10 BC plus 100 AC plus 10 BC plus C squared. So all you do is condense this, so you get 10,000 A squared plus 1000 times 2AB plus 100 times B squared plus 2 AC plus 10 times 2 BC plus C squared. So that one's really long, you're not going to memorize it, but if you do have it memorized, you could do 3-digit squares. So 12 squared, for instance, is C squared. So 2 squared is 4, 1 times 2 is 2, double it, we get 4. 3 times 2 is 6, double it, you get 12, plus 1 squared is, so 1 squared is 1, so 12 plus 1 is 13. Hopefully I'm doing this one right. So we get 3 times 1 is 3, double it, that's 6, plus the 1 is 7, and then 3 squared is 9. So hopefully if we did this correctly, 312 squared should be 97,344, and that is correct. So yeah, I don't expect you to memorize this one, but if you do, cool. I just felt like adding it because it's kind of like an extension of the 2-digit squares, but 2-digit squares are very helpful if you know the trick. I'll do one more trick to finish. This one's a lot simpler than this, so you don't have to worry there. It's just multiplying by 12, which has its own set of cases. So if we do 2-digit times 12, we get 10A plus B times 10 plus 2. So if we do that, we get 100A plus 10B plus 10 times A, 10 times 2A plus 2B. So if we condense it, we get 100A plus 10 times B plus 2A plus 2B. So let's go ahead and do this trick. So if we do 37, or yeah, let's do a 34 times 12. I mean, you could do double and half again or another trick, but essentially we get 4 times 2 is 8, and then we take 3 plus 8, so, oh wait, no, 4 plus 2 times 3, so 6 plus 4 is 10, carry the 1, and then we just write the 3 but with the 1, so 3 plus 1 is 4. So 34 times 12 is 408. So actually I'm going to flip this for the sake of keeping the A's in front. So 2A plus B. So here, the trick is just to double the ones digit and then write it. You double the second digit and add it to the second, and then just write the last digit. So if we did 12 times, let's do 21. So double the first ones digit, write it, double the second digit. So 2 times 2 is 4. Add it to the second digit. So that's 5. And then double this just write this digit. So 21 times 12 should be 252. And that's correct. So that's the 12s trick. So yeah, double one's digit, double second digit, add it to the next one, and then write down the last digit. And that's how you multiply by 12. And that'll conclude the number sets workshop. There's probably a couple of breaks. Of course, remember just to have a couple of these tricks names in mind, and then also the secret word, which was factor. But yeah, and thanks for watching.